In this simulation, you have two quantities. On the left, you've got a length, which can be negative as usual, or positive. You can change the angle as usual. You can change the range of values for the length. Changing this to 1,000, for instance, allows you to make lengths up to 1,000, but still down to negative 100. Over here, we have a representation of luminous intensity. The base unit for luminous intensity is the candela, and this number here represents, for instance, 50 candela. It's a measure of how much light is falling on an object. In this, you have a range that you can change. Let's say we go from 10 candela to 100 candela. Okay, that means the bottom is going to be 10 and the top's going to be 100. Also, changing it to the lowest value makes it pitch black, as if there's no light. This is the darkest light amount in the range. And changing it to the highest makes it bright white. Everything in between, let's say 90 or 80, gets progressively darker. So again, it's a visual simulation of amount of light that's falling on an object, and the range is from whatever this is to whatever this is, going from black to white. We can link length and amount of light by putting the name of the length in the definition of the amount of light. So for instance, if we say that the amount of light, f of x, is equal to the length, x, we can now, let's change this to 100. As we change the length, the luminous intensity also changes. As you just saw, if you go outside of the range, so for instance below 10, it simply disappears, gives you a dotted or square, and basically says we're not going to show you any information about this. It's outside the range that you set. But otherwise, that's how it works. Again, any function here, and this will change according to the function you put in. So that's that. It's luminous intensity versus length simulation.